to turn the recorder on here. Let me get that out of the way. So with the given information, first of all, for me to prove that this is congruent to this triangle, I've got to use one of the congruents, right? I got to either use side, 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 or side, or angle, side, angle, one of those.
Okay.
What do you notice? In other words, the only thing we know at the moment is that AB is congruent to DC. And we know that they're parallel. And we know that those vertical angles are equal. So we have one angle equal to another angle, and we have a side equal to a side. Well, what else are we going to require to prove this triangle is congruent to this triangle?
Either another side or another angle.
Right, and they haven't given us any information that's going to allow us to do anything with these sides. So definitely another angle. Which angles are equal? Based on the fact that the top and bottom lines are parallel. Think two parallel lines with a transversal. You actually have two parallel lines with two transversals. So which angles are equal?
Angle A and angle C.
Correct. What else?
Angle D and angle B.
Correct. Now we have angle, side, angle, right?
Yeah.
And that's enough to prove congruency. So we did it in our head, thinking it out, and now we got to turn it into a two-column proof. And that's always the best way to do these. Especially if you have to do the proof from scratch. If they give you a problem where, you know, there's 5 steps on the left and 5 reasons on the right, and they give you one for each row, then it's a whole different story. Then you have to kind of do it the way they've structured it. But when you have to do it from scratch, frequently there's multiple ways to do it. But this is by far the easiest. Now, you want to go through the two-column proof, the full thing?
Yeah.
Statements and reasons? Let's do at least one.
Okay.
Because they tend to be rather lengthy. What's the first statement? I'll give you the first reason. The first reason is always the givens.
Yeah, so line AB is congruent to line CD.
That's one of them. What else?
Line AB is parallel to line CD.
That's the only two things they gave us. Okay. So based on that, let's prepare our proof. What can you say next?
That angle E is congruent to...
No, you don't actually even need that. Notice that when we use the two parallel lines, we got A is equal to C and D is equal to B based on the fact that they're parallel. So let's not put any additional information that we don't really need. We don't really need to know that E is equal, it's a vertical angle with this one. I mean, that's a true statement, but in this particular problem, actually extra, we don't need it. So take our second statement, and I'll shorten it a little bit. Angle B is congruent to angle D, and angle A is congruent to angle C. Now, if you're doing this for a test or something, you'd want to define these angles better. In other words, angle A is not really angle A, it's angle BAE. know what I'm saying?
Yeah. Yeah.
And angle B is angle ABE.
Yeah.
So you would want to spell it out there. She may not let you get away with this shortcut notation that I've done here. What's the reason that 2 is true?
Because they're alternate interior angles.
Very good. Alternate interior angles. Okay? We're almost there. What's the
Okay.
third and last statement?
That triangle ABE is congruent to triangle CDE.
Because
Angle, side, angle.
that's it. There you go. And I'm sure that, you know, for reasons here, I mean, I don't know how specific your teacher insists you get. You know, I don't know if you have to say the parallel lines, alternate interior angles theorem for number 2, and number 3. I get you can just get away with angle, side, angle, can't you, for a reason or not?
Yeah, we can.
Okay, you should be able to. It'd be terrible
Yeah.
if they took points off because you didn't specifically name the theorem or anything like that. The names of those theorems are not important. It's what they do that's important, if you know what I'm saying.
Yeah, I do.
Okay. All right, let's see. I may have to. Okay. Now, we got a lot on here. Let's just, instead of doing the 2-column proof, tell me how you're going to do it. How are you going to prove that angle W is equal to angle Y? I guess they do let you get away with the shortcut notation now that I'm looking at 29.
Yeah.
What are we going to have to prove first before we can prove that? Almost certainly. What would make angle W equal to angle Y? What would have to be true about these two triangles?
Oh, the triangles would have to be congruent.
So that's our strategy. We're going to go after proving that this triangle is congruent to that triangle. Once we do that, we'll be able to say angle W equals angle Y for corresponding parts of congruent triangles are congruent. CPCTC or whatever that thing is.
Yeah.
Okay, so how are we going to prove this is congruent to that? How are we going to prove the triangles are congruent? So all I see is two sides.
Yeah. Would you do that XZ is like congruent to XZ?
Perfect. By which property?
That's the
Reflexive.
reflexive.
That's the reason everybody hates proofs, is because you actually have to prove that something is equal to itself and know why. That truly is the reason everybody hates proofs, is because that seems so silly. But nonetheless, that's what they force you to do. And then why is that triangle going to be congruent to that triangle? Based on which congruency?
Side, side, side.
Yep. And once you say that, now you can say W is equal to Y. Corresponding parts of congruent triangles are congruent.
Yeah, that makes sense.
But that's the way you want to do all of these. You want to figure out how you're going to do it in your head, and then go back to the beginning and start with the first step.
Mm-hmm.
PEA format. What is PEA format?
It's like a way that we learn to like write things out. So it's like the point is like saying what shape the graph
Okay.
like what shape
All
you're
right.
graphing.
I don't really need to know that, what PEA format is,
Yeah.
because I know how they want you to do this.
Mm-hmm.
Okay. First of all, I would graph those points. Let me do that real quick on my own. Ooh, I may have difficulties here. Hold on a second. How am I going to do this? Let's see. I'm still having a little trouble with your picture because I can't move it to the left. Let me see what I can do here. Boy, it doesn't even like me to do that. This Windows 10 needs a lot of work, even when I move that over.
Yeah.
All right, is all I need really. Now, see, I can't move it down or up. All I need is those 4 points and somehow enough room to draw. There we go. All right. So let's quickly put those 4 points on there. And I'm not going to bother to grid this thing up perfectly or put the points perfectly. I don't need to. I just need to know approximately where they're at.
Yeah.
Say that's A, minus 1 comma 4. Okay. And B is at 3 comma 5, which is about there. C is at 2 comma 1. Well, 2 comma 1 would be about there. And D is at minus 4 minus 2. Yeah, that's about there. So if I connect those, I don't expect to see the shape that it actually is because I approximated everything.
Mm-hmm.
We don't need to, though. We can tell that that's a quadrilateral, right?
Yeah.
It's not just going to be any old quadrilateral. Since they've asked you to prove what type of quadrilateral it is, well, what do you suspect it is?
Sailor Justine, are you deaf? No, I'm not deaf. I don't have it.
Connor?
Sorry, what?
It's okay. So what are we going to try to prove about this quadrilateral, for starters, to figure out what kind it is?
The distance?
Well, I suspect it's a parallelogram, right? It looks a lot like a parallelogram. Could be a trapezoid, but either way, if I'm trying to prove that that's either a parallelogram or a trapezoid, then it has to do with some parallel lines. In other words, if I can prove that AB is parallel to DC, and I can also prove that AD is parallel to BC, and then if I can prove that the slope of this line is the negative reciprocal of the slope of that line, I got me a parallelogram.
Okay.
Also, because of their directions use distance and slope to prove it,
Yeah.
well, the easy way would just be to use the slopes. Okay, let's look at the slopes, and then we'll go back. And the definition of a parallelogram is not only opposite parallel sides, but equal parallel sides. In other words, AB would also have to be the same distance as CD.
Yeah.
However, if I can just prove opposites are parallel and oh, that's not going to be perpendicular. Yeah, that would make it a rectangle if that was perpendicular. So slopes alone are, actually, if I can prove AB is parallel to CD and AD is parallel to BC, it's a parallelogram. But since they specifically requested we use slope and distance, let's figure out slope and distance. First of all,
Okay.
the slope of AB.
Well, you would do 5 minus 4 and then 3 minus -1.
Slope.
And you would get
5 minus 4 divided by 3 minus a minus 1. What is that equal to?
1 over 4.
Okay. Now let's figure out the slope of DC.
Okay, so
Spect is the same.
yeah. So it would be 1 minus -2 over 2 minus -4, and that would equal 3 over 6.
Ah, it's not the same. So CD is not parallel to AB, so it's not a parallelogram. Now let's check the slopes of AD, because if AD is parallel to BC, then we have a trapezoid.
Okay.
Slopes are always what you want to look at first, though. So what's the slope of AD?
So you would do 4 minus -2 over -1 minus -4,
Correct.
which would equal 6 over 3.
Uh-huh. So 6 over 3 is 2, right?
Yeah.
Okay, and finally the slope of the fourth line. And you can see that you know that you can do these in either order. In other words, I don't have to do y sub 2 minus y sub 1. I can do y sub 1 minus y sub 2 if I want, as long as I do the same direction with the x's.
Yeah.
Okay. And in a case like BC, it's much easier to subtract a smaller number from a bigger number. So I'm always going to do 5 minus 1 over 3 minus 2.
Yeah.
And that gives you 4 over 1. So that slope is 4.
Yeah.
So we don't have any parallel lines here.
No.
So it's, it could be a kite, huh? That looks like it might be a kite. Let's do distances.
Okay.
Do the distance between AB, distance. I'll bet you that AB is the same distance as BC, and that AD is the same distance as CD. That would make it a kite.
Okay.
So how do I do the distance for A to...
It's like the square root of x1 minus x2 squared plus y1 minus y2 squared.
Think of it this way. You're absolutely right in what you said, but it's the differences in the x's plus the differences in the y's. That's really the way to memorize. Okay, what's the difference in the x's? And since it's squaring, I don't care which way I go. All I need is the difference between the two x's. I don't care if it's minus 4 or plus 4. Because I'm going to square it, it's going to end up being 16 regardless.
Yeah.
So the difference in the x's squared is 16. What's the difference in the y's squared?
Um,
5 minus 4.
1.
1 squared.
So just,
Just 1.
yeah.
So that distance is square root of 17. Okay. Now let's find this distance, BC.
Okay.
Square root. Distances between the x are still 4. Whoops, sorry. I didn't do that right. Excuse me. Distances between the x's are what?
1 squared.
Is 1. Distance between the y's?
4.
Squared?
16.
Square root of 17 also. That means that side's the same distance as that side. And we're going to find the same thing, I guarantee it, for AD and CD. So up here, what's the distance from A to D?
Would that be -3 squared?
Which is 9.
Yeah. And then, would that be a difference of 6 for the y's?
Correct. And that's all you care. You don't care if it's negative or positive. There are 6 units between 4 and -2, regardless of how you do it. So this thing is square root of 45, and that can be simplified, but I'm not sure we need to. They didn't ask what the distances were. They just are wanting to figure out what this figure is. So now do CD. If it comes out to be the square root of 45, we've got a kite.
Okay, so for CD, the differences between the x would be 4 squared, which is 6.
What's the distance between 2 and -4?
Oh, 6 squared, so 36.
What's the distance between the y's?
3 squared, so negative.
So that is square root of 45, meaning this side here is the same as that side there, and that's the definition of a kite. Definition of a kite is it's a quadrilateral that has 2 adjacent sides that are equal, and the other 2 adjacent sides are equal also to each other.
Okay.
And that's all we need to prove what that shape was. Actually, that was quite a bit. Turned out we didn't need slope, did we?
No.
Not at all. But in looking at that figure, especially the way I drew it, it easily could have been a parallelogram. And so I was focused on slope from the get-go, so that's why I did all these slope calculations. But as soon as we did all 4 lines and we saw no slopes that were the same, then we knew that it was none of the figures that have parallel sides, like trapezoids or parallelograms. Then it became a problem of distances only, and that's probably why the instructions said distance and slope. And they actually, I guess, want you to figure out the slope anyway, since that was their instruction. Then use the distance and slope formulas to figure out what type of quadrilateral it is. Now, the PEA, what would that refer to the way we've done this problem when they're using PEA format? Is there anything else we would need to do?
No, after that it's just writing, and then the E is just like all the work that we did.
Okay. Okay. Cool. Well, it's 9 o'clock, Connor. I guess we'll have to do the rest. The problem with the three problems we did is they were all relatively long.
Yeah.
They weren't short problems. So in a half hour, we didn't really get a chance to do very much of it. Although, I don't know, we did 2 proofs and we did 30, which was a lot of work. So
Yeah, and I know that on Wednesday I have a half an hour session, and then next Monday I have a hour-long session.
okay, so we got plenty of time to finish this whole thing.
Yeah.
Okay. We're good to,
Well, thank you
we're
for
good
the help.
to go until Wednesday. I will talk to you Wednesday. Well,
Yeah,
hold on,
talk to you.
before you go, let me just verify that I got you on here Wednesday. I got you on at 7.
Yeah.
And that's another day you can see I'm booked up back to back. So if I'm 5 minutes late, just bear with me. I'll try to be on time, but it's awful hard to get out of a session and into another session in 0
Yeah.
minutes.
Okay, sounds good, and I'll will I need to send you these pictures again?
No. Once you send them, as long as I can read them and I can scroll up and down on this thing, I think I can read them all. So, yeah, I'm fine with what you sent.
All right.
In the future, it would be better if you can figure out how to send it as an attached file. This is not an attached file. This is actually part of the body of the email.
Yeah.
I don't need any special software to read this file. But if it's an attached file, then I can download it, I can rotate it, I can zoom in, zoom out, I can place it wherever I want. So I can actually do a little bit better job of it if you send it as an attached file. Unfortunately, I'm not sure I know how to tell you to do that because I don't have an Apple. But maybe your mom or your dad know how to send as an attached file. You have to take the photo and then you have to kind of, on my smartphone, I go to my gallery, I bring up the photo, and then I say share it. And then I type in the email address and it attaches it as a file.
Okay.
Okay. So it's nothing similar on the Apple. I know that. You go to the photo after you've taken it and then I don't know if it's called share or what, but you want to send it as an attached file, large image. But this will work for all of our stuff.
Okay, well, I'll mess around with it more and see if I can get it figured out for like the future.
Okay. Sounds good.
All right. Thank you for your help.
Sure. Have a good rest of your evening, and I'll talk to you on Wednesday.
Sounds good. Talk to you Wednesday.
Bye-bye.